What the actual... job?
Hello, I'm your host, Matt Fraser, and welcome back to What the Actual Job, where I interview individuals about their careers so that high school students can gain a better understanding of the jobs they'd like to pursue in the future. Today's interview is with Stephen Ferguson, a neuroscientist with U Ottawa.
My name is Dr. Stephen Ferguson. I am Distinguished Research Chair at the University of Ottawa, in the Department of Cellular and Molecular Medicine, and a scientist at the University of Ottawa Brain and Mind Research Institute.
So what does a typical day look like for you?
I drive to the General Hospital campus, which is where the medical school is, because it's not on the main campus of the University of Ottawa. It's associated with the hospitals. Try and find a parking space, go to my office, and sit down, turn on my computer, and go through the 30 or 40 emails that are waiting for me.
Yeah.
That will completely change what I had planned to do that day.
What activities do you tend to do day to day?
Recently, I don't get to do much research things with respect to my lab because they have to take care of them themselves. Right now, I'm in the midst of putting together a letter of intent for a large infrastructure grant for $20 million with another colleague.
Oh, wow.
So it takes up a fair bit of time. I spend a lot of time writing grants so I can fund the lab and salaries the people that work for me. When I get a chance, I sit down and I talk to them about the research. Once a week, I have a meeting with the entire lab where somebody presents their data. Right now, I'm in the midst of part of the year where I do teaching, and I never really know what's going to happen on a given day because there's always something unexpected.
What do you like most about being a neuroscientist?
I like interacting with my students and postdocs. I like it when we get new results, but learn things.
Yeah.
I like the unexpected results. I'm not very excited by the expected results.
Oh, really?
Anything you expect is not really all that interesting. Things you don't expect that send you in directions that are far more interesting.
I suppose that's right, yeah. And then what would you say, I guess on the opposite end, is the hardest part about being a neuroscientist?
Being a university professor. So I started off my career at a research institute where I was protected from teaching, and I had all of my time dedicated to research. I liked life way better back then.
Yeah.
Didn't have the politics, I didn't have the teaching, I didn't have the administration, I didn't have 6 or 7 levels of bureaucracy on top of me. When I asked for a new phone jack or something, within 30 minutes to an hour, there was somebody in my office putting in a big phone jack. Now, when I need my garbage changed, it happens once every 30 days.
Oh, wow. So do most neuroscientists become professors?
No.
Uh,
Neuroscientists can work in industry, they can work in government. Neuroscientist is sort of, I don't really consider myself a neuroscientist. I was trained as a molecular pharmacologist. I did my postdoctoral work on beta-adrenergic receptors and how they're regulated, describing a new signaling pathway that sort of revolutionized how people think of these receptors that contribute to every single disease you could think of.
Oh, wow.
The most popular G protein coupled receptor right now that's being targeted is the target of Ozempic, which everybody's heard of in the news. So my interest has always been more cell biology, except when I moved back to Canada, so I wasn't competing against my former supervisors, one of which got a Nobel Prize in 2012.
Oh, wow.
I was working on a receptor that they weren't working on and happened to be in the brain.
That's really
sick.
sick.
I became a neuroscientist.
That's really, really cool. What is the most valuable or significant thing you've learned from your career so far?
Not to follow the expected, to go after the unexpected, because that's where the interesting stuff is, because that's where new ideas and new concepts come from in biology. If everything worked the way we thought it worked, we'd still be in the Middle Ages, bronze swords against each other. Every once in a while, there's major breakthroughs, and you need to incorporate those into your research program. You've probably heard of CRISPR-Cas9 for gene editing, so we change the human genome. We use those technologies in my lab to manipulate cells. We have mice that have had manipulation by CRISPR-Cas9. It's a very powerful but a very dangerous technology if used unscrupulously by governments.
That's really cool, though. That's a great perspective. I haven't really thought about things like that, but looking for the unexpected and using that is, I think, a really good lesson and valuable thing.
Because you're looking for what you don't know, right?
Yeah.
So if you think you know the answer, then why'd you ask it in the first place? So that's why scientists talk about a null hypothesis. You're trying to prove yourself wrong and do an experiment. And when you do prove yourself wrong and you find something other than what you expected, you find something that's oftentimes far more interesting.
Yeah, that's really great. Is your career what you thought it would be when you started, and are there any expectations that turned out different from reality?
I think I've done better than I expected to do.
Oh.
Becoming a scientist is not an easy thing.
Yeah.
People starting out in university and grad school, about maybe 1 in 20 make it on to become a research scientist or a university professor. I wasn't prepared for the politics that have crept their way into science.
Yeah.
I expected that. I get a little bit disturbed by the politics of EDI because my laboratory has always reflected a very diverse group of people. Because those are the kids that are coming through universities. And I hire people from around the world as postdocs. I've had several postdocs from Brazil, postdocs from Ireland, Germany, Saudi Arabia, Egypt, Japan, even in America. Science is a very diverse thing. We don't have enough talent homebred in Canada. Canada is a pretty diverse country as it is. Diversity is a necessity in science. And you need different perspectives to get different answers. The one thing that has come to really surprise me is some of how the difference between male and female physiology work. It's not just X chromosome versus XY, and testosterone and estrogen. Things like Alzheimer's. Alzheimer's looks the same in men and women, and it presents the same way most of the time. But there are molecular mechanisms underlying the disease process that are completely different between men and women. At the single receptor level, at a level I would never expect to have seen. It came as a big surprise to me.
Wow.
For example, we were doing studies with a drug that we had showed if we knocked out the receptor in mice, but we'd only done it in male mice, that it reversed the cognitive deficits in the mice.
Whoa.
So when we tried the drug, it was really effective in male mice, but it did nothing for the female mice.
Huh.
And we've been able to go on and figure out why that is.
Yeah.
I can't say I was really happy about the results because at the time my mother-in-law was in the end stages of Alzheimer's disease.
Yeah.
I would really like to see something that was beneficial for women because Alzheimer's affects women twice as often as men, even if you correct for life expectancy. So why is it that women are more susceptible to Alzheimer's disease, and why is it occurring by potentially different pathways in males versus females?
Yeah.
So, that's one aspect of science that has been political that's not been bad. I always thought a receptor was a receptor was a receptor. It doesn't matter what you put it into, whether it's a cell, a man, or a woman, it would behave the same way. And so my biggest surprise was, no, that's not the case.
Yeah, that's interesting. And also, I can understand how that's kind of annoying as well, where you're like, oh, this isn't working the way I kind of hoped it to be.
Decided to target a different receptor, found a new drug that could work for both women and men. So it'll never make it to market, but that's okay. That's the other big surprise is there's a lot of people out there that believe that we're hiding the results of our experiments. And I've come to discover that drug companies do keep certain things down so they can profit more. It's not run by the scientists. The pharmaceutical companies are run by MBAs.
Interesting.
We're all about money.
Yeah.
And that's become a big disappointment to me as a scientist.
What education or training or schooling, etc., did you do to become a neuroscientist?
When I went to university, I chose to do behavioral ecology.
Oh, cool.
And I hated it.
Oh.
There wasn't neuroscience programs back then. I went to McGill University, which was probably the leading neuroscience place in Canada at the time because of the Montreal Neurological Institute. And they did have a neuroscience program in the upper years of school. And I happened to get a job at the Montreal Neuro one summer and decided that, maybe I'll do neuroscience. And then I did a PhD in pharmacology. Then I did a postdoctoral fellowship at Duke University with the late, great Marc Caroon, who was a French-Canadian working with Bob Lefkowitz. And two of them made major discoveries in receptor science. Bob took all the credit, got the Nobel Prize. And then I applied for a job. At the time I was looking for a job, and I chose one in London, Ontario, which is where I was from, at a research institute that was independent of the university. Virtually, it eventually went bankrupt and ended up at the University of Ottawa. Another way to become a neuroscientist is to go to medical school, whereas you're doing your fellowship, you can specialize in you may go into neurology and neurosurgery. Many people after postdocs and sometimes straight out of their PhDs will go into industry. Industry is interested in a lot of neurological targets.
Yeah.
Between neuromuscular diseases, which is neurological, stroke,
and
things like anxiety and depression. I've had students go on to do law degrees and become lawyers in patent law. So there's lots of different opportunities and pathways. You could be a neuroscientist coming from just about any field you could think of.
What do you think makes an excellent neuroscientist?
I haven't got a clue. There's different ways to be an excellent neuroscientist. I prefer to do it by being an excellent person. For me, I get more gratitude or gratification out of being able to work together with my students and postdocs and facilitate their findings rather than sitting back and saying, this is what I want to see happen. It's not a question I can really answer. What makes a good neuroscientist? It's like asking what makes a good person.
Are there any skills or qualities you think someone should have?
You've got to be imaginative, dedicated to a certain extent. To succeed, it's not a 9-to-5 job. It's certainly not a 10-to-3 job.
Yeah.
There's no such thing to be a successful neuroscience. There's no such thing as a work-life balance.
Yeah.
To get to the top of one's field, as my postdoc supervisor used to like to say, 95% of good luck is hard work. And you have to like what you're doing. If you hate what you're doing, you're never going to do well.
So how do you make a memorable impact?
I don't know, to be honest. We had an internal seminar series on neuroscience and aging yesterday, and there was a small reception afterwards. The students started talking to me and introduced themselves and say it was the lab next door. So your students really like you. Oh, good. I really like my students. So I find it gratifying that my students like me. They appreciate me. Last year in Brazil, former postdocs put together a meeting that I didn't realize was in my honor.
Oh, wow.
So at the end of the meeting, they got up and did this huge roast of me. I don't like being the center of attention, so it was embarrassing. I hope that some of the things that I've done in my career will have made an impact. I think a few of them have. Some of the stuff that I've done is in textbooks. So I guess that's one measure of success. I guess you're successful if you can keep funded in the Canadian scientific community. The funding rate for CIHR for research scientists is less than 15%. Thousands of very qualified scientists competing for a very small amount of money with a very small success rate. Yeah. And I've been fortunate enough to be quite well funded for 30 years. I've been an independent investigator and still seem to be able to manage to get my grants funded.
Do you have any advice for someone who wants to become a neuroscientist?
Pick a good university that has a good neuroscience program. For an undergraduate, if you just stay in Ottawa in neuroscience, surprisingly enough, Carleton has the best undergraduate program, in my opinion. I'm also crossing the way to Carleton, so I can say from a graduate point of view, I think Ottawa has probably a slightly better graduate program just because it's bigger.
Yeah,
There's more opportunity and diversity because the hospitals that are associated. Still really excellent scientists at Carleton as well. If you're really serious in neuroscience in your career, very early on, try and get yourself into a laboratory in the summertime as a volunteer or as a summer researcher. They'll then take you on as a fourth-year honor student doing a research project. And more often than not, if you do well through all that, you'll find yourself finding it much, much easier to find a grad school mentor, which is the hardest part. Is finding somebody to take you on as a graduate student. Think ahead. Keep your eyes open. If you're interested in neuroscience now, you might see something in university that you find more interesting.
We actually have some questions from some students. And the first one is, where do neuroscientists tend to work? Hospitals, universities? Both?
Because hospitals have research institutes which hire scientists, and many of them are neuroscientists. Universities have neuroscientists in their faculties, psychology, medicine, etc., biology. Neuroscientists will work in industry. As I said, they could be in government, doing government policy, lawyers, you name it.
That's really interesting. Do neuroscientists ever get involved with surgeries or operations on the brain?
Not directly. They may be there if they're lucky enough to have a collaboration with a neurosurgeon who can provide them with tissue. So, example, if somebody's undergoing an operation for epilepsy, where you've got a piece of tissue that's sending sending electrical stimulations that's causing people to have really serious epileptic fits that can't be cured with drugs. They'll take that tissue out, and rather than throwing it out, they might give it to a neuroscientist to study the electrical properties. But no, you need to be a clinician to be able to do neurosurgery, period.
And then the final question is, if you had to choose 3 challenges or diseases that affect the brain, which 3 do you think are most important to research and study as a neuroscientist?
So when people submit their grants, they tell you that their disease is the most important disease. And if you think about it, really, no disease is more important than another disease if you happen to be somebody who has that disease or have a family member or a friend affected by the disease. So the rarest disease in the world is a brain disease called Creutzfeldt-Jakob's disease. There's only 33 Canadians in Canada that have had the disease, the disease at any given time. Unfortunately, a very close friend of mine died of the disease a couple of years ago. It's like winning the ante-lottery. Right?
Yeah.
1 in a million chance.
Wow.
It's the human version of mad cow disease.
Oh, okay.
I think it's a really important disease to study because of how important what it tells us about the brain.
Yeah.
But another person will tell you that cancer is more important. But really, any disease in the brain is just as important as another if you happen to be a patient with that disease. So I find, for me, Huntington's is a very interesting disease. I spend a lot of time studying that. It only affects 1 in 10,000 people. Alzheimer's affects 30% of people by the time they're 85 years of age. So you could say that was more important. If you had a child with brain cancer, God knows that's one of the most horrible things that can happen.
Yeah.
Some diseases strike more emotions than another. But I can't really say there's one disease that I think is more important than another disease. They're all important to the people who have the diseases. And fortunately, there's people with expertise interested in all those different aspects of disease. So you can only do so many things. My lab has worked on anxiety and depression, Alzheimer's disease, and Huntington's disease over the years. I'm not saying that those are the most important diseases, but those are the ones which have caught my interest because of certain findings that we made earlier on in my career with respect to how proteins interact with the receptors that I study.
That was a great answer to that question, by the way. That was really great.
No disease is more important than other disease.
Yeah.
Especially if you're a person that's afflicted with television shows on the weekend where they make you cry over sick babies, etc. And it's really terrible.
Yeah.
Nobody wants to see a sick child. But I think trying to pretend that one disease is more important than another, I don't think it's the way to go.
Yeah.
That's just my own personal opinion.
Thank you very much for coming. Do you have any
my pleasure.
Last comments? Or
it's different than working a 9-to-5 job in an office.
Yeah.
And you have a little bit more freedom to do the things that you want. You control more what you want to do with your life than you can in most jobs.
Okay.
Except when they tell you what you have to do.
Yeah. Thank you so much, Mr. Ferguson, for that amazing interview about a career in neuroscience. If you want to listen to this episode or others like it, you can listen here on CKCU 93.1 FM or wherever you listen to podcasts.